Now we're going to look at the characteristics of stars graph that's found on page 15 of your reference table. Now what this graph does is it plots out stars and star groups based on 4 characteristics. These characteristics are listed along the x and the y axes, so let's begin there. On the x-axis, the horizontal axis, you will see surface temperature in Kelvin. Now when you look at the scale, there's just something a little bit different about this scale. As you examine the temperatures, they begin with the highest value of temperature, 30,000 Kelvin, all the way to the left-hand side. And then as you move to the right, the temperatures decrease until you get to the smallest value of 2,000 Kelvin. That's a little bit opposite the way we would normally create a scale, so we just need to be aware that that's what you find here. Also, on this x-axis, you will find a related variable, and that is star color. And you see the listing out of the different colors, beginning with blue all the way to the left, meaning then that blue is the color of the hottest stars, because we see the highest temperatures along that scale there. And then as you move towards the right, you grade through blue-white, white, yellow, orange, and finally red, which will place you all the way towards the right-hand side of the scale, meaning red is the color of the coolest stars. Now if we take a look at the y-axis, we see the label luminosity. Luminosity refers to the brightness of a star. But in this case, it is a relative term. It is compared to the brightness of our sun. So at a value of 1 in terms of luminosity, you will see that is where our sun is placed. So as we evaluate this, any star that would place at a luminosity greater than 1 would be comparatively brighter than our sun. Any star placed at a luminosity less than 1 would be less luminous or dimmer than our sun. Now there is another scale that is found along that y-axis, but we have to go all the way to the right-hand side of the graph to see it. You'll see the label massive stars and small stars. What we're really talking about, and it goes along with luminosity, it's a related variable, we're overall looking at the size of the star. So again, there are 2 variables that are listed along this axis. They are luminosity and size. You just need to make sure you look at both sides of the graph. Now let's look at the interior of the graph. Individual stars are named and represented by crosshairs. For example, some that we are familiar with. Polaris, we see Rigel, Betelgeuse, Bernard's star, Alpha Centauri, which is very, very close to our sun. We do see these, and they are labeled, and you can read their values of temperature, color, luminosity, and size just by reading to the proper axis on that scale. Now, stars that stack one on top of the other, like the Sun and Alpha Centauri, okay, these are a couple of good stars to take a look at. Notice how they do stack one on top of the other, which would mean that in terms of temperature and color, they have the same values. They would be yellow stars with a temperature of about 5,100 Kelvin. But they vary as you go to the luminosity and size scale. In that case, then we do see a difference. Alpha Centauri, being above the sun, would be more luminous than our sun and would also be bigger than our sun. Now, something else we can examine as we look at the interior of the graph is we can look at the at the star groupings. What I mean by this is you'll see the labels main sequence, supergiants, giants, and white dwarfs. Those star groupings are all clusters, and they give you characteristics, the characteristics of groupings. One other thing that you will see underneath, in parentheses, underneath the name of the star group, is there's a reference to their stage of development. For example, here we see under main sequence, early stage. So what we learn from that is that most stars begin in the main sequence. They begin their lives in the main sequence, and they spend a good amount of their lives in the main sequence. Our sun, for example, is a good example of a main sequence star. We see that it fits right there in that cluster. Okay. But then as they age, as they leave that main sequence, stars expand. And that leads us to the intermediate stages. Either stars will become supergiants or giants. Now, what's going to be the determining factor? The starting mass of that sun. If they are just average to small, when they expand, they become giants. When they are more massive stars, when they expand in that intermediate stage, they become supergiants. But after that intermediate stage, as the stars begin to reach, the end of their life cycle, the later stages of their life cycle, they collapse downwards, and that's where we see white dwarfs, and the label late stage under the white dwarfs. So we've got a lot of information here. What can we do with it? How might we be asked about it? Well, let's just take a look at a couple of general questions. I've still got the graph here, but we also have a couple of questions. The first one, which star has a higher luminosity and a lower surface temperature than the sun? All right, higher luminosity than the sun. You remember our luminosity was here on our y-axis. The sun gives us our starting point at that value of 1. Higher luminosity is going to place whatever our answer is going to be up here in this upper part of the chart. Okay? But that's only one half of the question. Now, the other part of it says, and a lower surface temperature than the sun. Lower surface temperature, which means now, as I look at temperature, lower, cooler, is always going to be to the right-hand side. Here's our sun again, so I want to go to the right, but I'm going to see now, let's see if we can overlap. Okay, cooler is going to be something right up here. So I've really narrowed down the part of the graph that I'm interested in. Now let's just look at the stars. Rigel, first example, over here, not going to work. Bernard star, over here, not going to work. Alpha Centauri is, if we recall, exactly the same temperature. So it is not lower temperature than the sun. Aldebaran, oh yeah, we got them right there, squarely in that area of the graph that we identified. So there's our right answer. Let's take a look at the next question, our next example. Which of the following stars has a surface temperature of approximately 9,000 Kelvin and a luminosity 1 to 20 times greater than the sun's luminosity? All right, let's start with what they give us. A temperature of 9,000 Kelvin. So that's going to put me just about here. Okay, I'm going to go straight up. My line's a little crooked, but there we go. And a luminosity 1 to 20 times greater than the sun. Now, here's our sun, right, at the value of 1. So 1 to 20. So I'm going to want something that's going to be over, and I'll stay on my line, somewhere that's going to be here, 1 to 20 times greater. What are my choices? First one says serious. Well, I like that. That actually looks right in my area. Well, let's just make sure. Procyon B, not there. Rigel, no good. Polaris, nope. It was indeed Sirius. So just take your time. You know where the different values are, the different variables. Just take your time and hunt down the information you need, and you'll be in good shape.